Today we are going to discuss the topic Discrete Time Fourier Transform or DTFT. So first we are going to study about Discrete Time Fourier Transform pair. That means one is a Discrete Time Fourier Transform or analysis equation, or second one is inverse Discrete Time Fourier Transform or synthesis equation. Those two are called as Fourier Transform pair. So first one, discrete time Fourier transform or analysis equation is given by x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n, and inverse discrete time Fourier transform or synthesis equation is given by x of n is equal to 1 divided by 2 pi integration 2 pi x of e power j ohm into e power j ohm n into d ohm. For example, find the Fourier transform of x of n is equal to 2 into 3 power n u of minus n using analysis equation. We know that Fourier transform equation x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n, which is equal to summation n is equal to minus infinity to infinity x of n is replaced by the given equation 2 into 3 to the power n u of minus n into e power minus j ohm n, which is equal to, it is given u of minus n, summation n is equal to minus infinity to 0, 2 into 3 to the power n into e power minus j ohm n. Put m is equal to minus n, then when n is equal to minus infinity, m is equal to infinity, and n is equal to 0, m will be 0. Therefore, x of n is equal to summation n is equal to infinity to 0, 2 into 3 to the power minus m into e power j ohm into m, which is equal to summation n is equal to 0 to infinity 2 into 1 divided by 3 into e power minus j ohm whole to the power n after rearranging the equation. It is geometric series of the form a into r to the power n whose summation gives a divided by 1 minus r. That is, x of n becomes 2 divided by 1 minus 1 divided by 3 into e power minus j ohm, where 1 divided by 3 into e power minus j ohm represents r. After rearranging, we will get 2 divided by 1 minus e power j ohm divided by 3. Use the Fourier transform synthesis equation to determine the inverse Fourier transform of x of e power j ohm, where mod of x of e power j ohm is equal to 1, where ohm varies between 0 to pi by 4, and 0 where ohm varies between pi by 4 to pi, and angle of x of e power j ohm is equal to minus 3 ohm divided by 2. Then we know that x of n is equal to 1 divided by 2 pi minus pi by 4 to 0 e power minus j 3 ohm by 2 into e power j ohm n into d ohm plus integration 0 to pi by 4 e power minus j 3 ohm by 2 into e power j ohm n into d ohm. So combining the common terms, we get 1 divided by 2 pi integration minus pi by 4 to plus pi by 4 e power minus of n minus 3 by 2 into j ohm into do, which is equal to 1 divided by 2 pi e power minus of n minus 3 by 2 into j ohm divided by n minus 3 by 2j, where limit varies between minus pi by 4 to plus pi by 4, which is equal to 1 divided by 2j into pi into n minus 3 by 2 into e power minus j into n minus 3 by 2 into pi by 4 minus e power j into n minus 3 by 2 into pi by 4, which is equal to 1 divided by pi into n minus 3 by 2 into sin pi by 4 into n minus 3 by 2, and x of n is equal to 0 for n is equal to plus or minus infinity. Next, we are going to discuss about discrete time Fourier transform of basic signals. For the signal x delta of n, the Fourier transform is 1, and the signal a to the power n into u of n, where mod of a is less than 1, the Fourier transform will be 1 divided by 1 minus a into e power minus j ohm. And the next signal x of n is equal to 1, where magnitude of n less than or equal to m, and 0 when magnitude of n is greater than m. Then the Fourier transform will be sin of 2m plus 1 into ohm by 2 divided by sin of ohm by 2. Next signal is sin of m into n divided by pi n, where m varies between 0 to pi. Then the Fourier transform will be x of e power j ohm is equal to 1, where magnitude of ohm varies between 0 to m, and 0 where magnitude of ohm varies between m and pi, and ohm is equal to 2 pi. Next signal is summation k is equal to n x of k into e power j k ohm naught into n, where ohm naught is equal to 2 pi by n. Then the Fourier transform will be 2 pi into summation k is equal to minus infinity to infinity x of k into delta of ohm minus k into ohm naught, where x of k is discrete time Fourier series coefficient. Next, we are going to discuss about properties of discrete time Fourier transform. So, first property is linearity. The statement is if x of n, if you take discrete time Fourier transform, we get x of e power j ohm, and y of n, if we take discrete time Fourier transform, we get y of e power j ohm. Then a into x of n plus b into y of n, if we take discrete time Fourier transform, we get a into x of e power j ohm plus b into y of e power j ohm. So, proof for this property is, let x of e power j ohm is equal to summation n is equal to minus infinity to infinity a into x of n plus b into y of n into e power minus j ohm into n, which is equal to summation n is equal to minus infinity to infinity a into x of n into e power minus j ohm n plus summation n is equal to minus infinity to infinity b into x of n into e power minus j ohm n. which is equal to a into summation n is equal to minus infinity to infinity x of n into e power minus j ohm n plus b into summation n is equal to minus infinity to infinity x of n into e power minus j ohm n. So which is equal to a into x of e power j ohm plus b into y of e power j ohm. Next property is time shifting property. If x of n, if we take discrete time Fourier transform, we get x of e power j ohm. Then if we take discrete time Fourier transform of x of n minus m, then we'll get e power minus j ohm m into x of e power j ohm. When the signal is shifted, the magnitude of its Fourier transform remains unaltered, whereas a phase shift is introduced into its transform. Let us prove this. Let y of n is equal to x of n minus m. Then y of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n minus m into e power minus j ohm into n. Put k is equal to n minus m, then n is equal to m plus k, which is equal to summation k is equal to minus infinity to infinity x of k into e power minus j ohm into m plus k, which is equal to e power minus j ohm m taking outside. So inside the summation k is equal to minus infinity to infinity x of k into e power minus j ohm k, which is equal to e power minus j ohm into m into x of e power j ohm. Next property is time expansion property. If discrete time Fourier transform of x of n is x of e power j ohm, then discrete time Fourier transform of x of a n is equal to x of e power j ohm divided by a, where n is multiple of m. Let us prove this. Let y of n is equal to x of a into n, y of e power j ohm is equal to summation n is equal to minus infinity to infinity x of a n into e power minus j ohm into n. Put k is equal to a n and n is equal to k by a. Then summation k is equal to minus infinity to infinity x of k into e power minus j into k by a, which is equal to x of e power j ohm divided by a. For example, find the Fourier transform of the sequence shown. The sequence is given and this signal can be split into two signals as x1 of n and x2 of n, and their summation gives x of n, that is x of n is equal to x1 of n plus x2 of n. So x1 of n is given, the amplitude of the signal will be 1 and x2 of n, amplitude of the signal will be 2. Let y of n be as shown, it is amplitude will be 1. Then x1 of n is equal to y of n by 2 and x2 of n is equal to 2 into x1 of n minus 1. Let g of n is given with amplitude of the signal will be 1. Then if we take discrete time Fourier transform of g of n, will get sine of ohm into 2 plus half divided by sine of ohm by 2, which is equal to sine of 5 by 2 ohm divided by sine of ohm by 2. Then y of n is equal to g of n minus 2. If we take discrete time Fourier transform, we get e power minus 2 j ohm into sine of 5 by 2 ohm divided by sine of ohm by 2. Then x1 of n, which is equal to y of n by 2. If we take discrete time Fourier transform, we get e power minus 4 j ohm into sine of 5 ohm divided by sine of ohm, or x2 of n is equal to 2 into x1 of n minus 1. If we take discrete time Fourier transform, we get 2 into e power minus 4 j ohm into sine of 5 ohm divided by sine of ohm into e power minus j ohm, which is equal to 2 into e power minus 5 into j ohm sine of 5 ohm divided by sine ohm. Therefore, e power minus 4 j ohm into sine of 5 ohm divided by sine ohm into e power minus j ohm plus 2 into e power minus 5 j ohm into sine of 5 ohm divided by sine ohm. Then x of n is equal to x1 of n plus x2 of n. If we take discrete time Fourier transform, we get e power minus 4 into j ohm into 1 plus 2 into e power minus j ohm into sine 5 ohm divided by sine ohm. Next property is conjugation property. Conjugation property states that if x of n, if we take discrete time Fourier transform, we get x of e power j ohm, then discrete time Fourier transform of x star of n is equal to x star of e power minus j ohm. Let us prove this. X of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n. Then x star of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm into n whole star, which is equal to summation n is equal to minus infinity to infinity x star of n into e power j ohm n, which is equal to DTFT of x star of n. Next property is frequency shifting property. If x of n, if we take discrete time Fourier transform, we get x of e power j ohm, then DTFT of e power j lambda n into x of n. If we take, we get x of e power j into ohm minus lambda. Let us prove this. Let y of n is equal to e power j lambda n into x of n. Then y of e power j ohm is equal to summation n is equal to minus infinity to infinity e power j lambda n into x of n into e power minus j ohm n, which is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm minus lambda into n, which is equal to x of e power j into ohm minus lambda. Next property is differentiation in frequency. Statement for this, if x of n, if we take DTFT of that, we'll get x of e power j ohm, then DTFT of n into x of n is equal to j into d by d ohm of x of e power j ohm. So proof for this, x of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n into e power minus j ohm n. Then differentiation of x of e power j ohm, that is d into x of e power j ohm divided by d ohm is equal to summation n is equal to minus infinity to infinity minus nj into x of n into e power minus j ohm n. Then j into differentiation of x into e power j ohm divided by d ohm is equal to summation n is equal to minus infinity to infinity n into x of n into e power minus j ohm n, which is equal to DTFT of n into x of n. Next is convolution property. DTFT of x of n is x of e power j ohm, then DTFT of y of n is equal to y of e power j ohm. Then x of n star y of n, if we take DTFT, which will be x of e power j ohm into y of e power j ohm. So let us prove this. Let z of n is equal to x of n star y of n. Then z of e power j ohm is equal to summation n is equal to minus infinity to infinity x of n star y of n into e power minus j ohm into n, which is equal to summation n is equal to minus infinity to infinity summation k is equal to minus infinity to infinity x of k into y of n minus k into e power minus j into ohm into n, which is equal to summation k is equal to minus infinity to infinity x of k into summation n is equal to minus infinity to infinity y of n minus k into e power minus j into ohm into n. Then put n minus k is equal to m, therefore n is equal to m plus k, which is equal to summation k is equal to minus infinity to infinity x of k into summation m is equal to minus infinity to infinity y of m into e power minus j ohm into m plus k, which is equal to summation k is equal to minus infinity to infinity x of k into e power minus j ohm k into y of e power j ohm, which is equal to x of e power j ohm into y of e power j ohm. Next property is modulation property. If DTFT of x of n is x of e power j ohm and DTFT of y of n is y of e power j ohm, then DTFT of x of n into y of n is equal to 1 divided by 2 pi x of e power j ohm star y of e power j ohm. Application of the modulation property is the effects of truncating a signal on its frequency domain representation. The process of truncating is a signal is known as windowing. Let us prove this. discrete time Fourier transform of x of n into y of n is equal to summation n is equal to minus infinity to infinity x of n into y of n into e power minus j into ohm n, which is equal to summation n is equal to minus infinity to infinity x of n into 1 divided by 2 pi integration minus pi to pi y into e power j ohm into e power j lambda into n d lambda into e power minus j ohm n, which is equal to 1 divided by 2 pi integration 2 pi summation n is equal to minus infinity to infinity y of e power j ohm into x of n into e power j into lambda minus ohm into d lambda, which is equal to 1 divided by 2 pi integration 2 pi y of e power j ohm summation n is equal to minus infinity to infinity x of n into e power j into lambda minus ohm into d lambda, which is equal to 1 divided by 2 pi integration 2 pi y of e power j ohm into x of e power j ohm, which is equal to 1 divided by 2 pi x of e power j ohm star y of e power j ohm. Next property is accumulation property, that is summation m is equal to minus infinity to infinity x of m is equal to 1 divided by 1 minus e power minus j ohm into x of e power j ohm plus pi into x of e power j 0 summation k is equal to minus infinity to infinity delta of omega minus 2 pi into k. For example, derive the Fourier transform x of e power j ohm of the unit step x of n is equal to u of n. Let g of m is equal to delta of n, then discrete time Fourier transform of delta of n is equal to 1. X of n is given, it is u of n, which is equal to summation m is equal to minus infinity to infinity g of m. Taking Fourier transform on both sides, we get x of e power j ohm is equal to 1 divided by 1 minus e power minus j ohm plus pi into summation k is equal to minus infinity to infinity delta of ohm minus 2 pi into k. Next is Parseval's theorem. The statement is if x of n and x of e power j ohm are a Fourier transform pair, then summation n is equal to minus infinity to infinity mod of x of n square is equal to 1 divided by 2 pi integration 2 pi mod of x of e power j ohm whole square into do, where LHS is the total energy in the signal x of n and RHS is the integration of the energy per unit frequency, and mod of x of e power j ohm whole square is the energy density spectrum of the signal x of n. Let us prove this. Summation n is equal to minus infinity to infinity mod of x of n square is equal to summation n is equal to minus infinity to infinity x of n into x star of n, which is equal to summation n is equal to minus infinity to infinity x of n into 1 divided by 2 pi integration 2 pi x of e power j ohm into e power j ohm n into d ohm star. Rearranging the terms, we get 1 by 2 pi integration 2 pi x star of e power j ohm into summation n is equal to minus infinity to infinity x of n into e power minus j ohm n into d ohm, which is equal to 1 divided by 2 pi integration 2 pi x star of e power j ohm into x of e power j ohm into d ohm, which is equal to 1 divided by 2 pi integration 2 pi mod of x of e power j ohm square into d ohm. For example, let x of e power j ohm denote the Fourier transform of the signal x of n. Depicted in the figure, it is given the signals at different instance it is given. We have to evaluate integration minus pi to pi mod of x of e power j ohm square into d ohm. Then summation n is equal to minus infinity to infinity mod of x of n square is equal to 1 divided by 2 pi integration 2 pi mod of x of e power j ohm whole square into d ohm, or integration minus pi to pi x of e power j ohm square into d ohm is equal to 2 pi into 1 plus 1 plus 2 square plus 1 plus 1 plus 2 square plus 1 plus 1. This is from the given figure, amplitude of the signal. So after simplification we get 28 pi. That is integration minus pi to pi d into x of e power j ohm divided by d ohm square into d ohm. Then n into x of n, if we take DTFT, we get j into d by d ohm of x of e power j ohm and minus j into n into x of n. If we take DTFT, we get d by d ohm of x of e power j ohm, which is equal to summation n is equal to minus infinity to infinity n into x of n, that is mod of n into x of n whole square is equal to 1 divided by 2 pi integration 2 pi mod of d into x of e power j ohm divided by d ohm square into d ohm, which is equal to integration minus pi to pi mod of differentiation of x of e power j ohm divided by d ohm square into d ohm is equal to 2 pi into 3 square plus 1 square plus 0 plus 1 plus 3 square plus 8 square plus 5 square plus 7 square, which is equal to 2 pi into 9 plus 1 plus 0 plus 1 plus 9 plus 64 plus 25 plus 49, which is equal to 316 pi.